Hello, welcome to Calculus Problems with Dorian. We are going to be working with homework 1, problem 12, which is P equals sine Q plus cosine Q over sine Q, and we're going to be deriving this monster of a function. Now, since the denominator is the same, we can separate this fraction into two fractions, sine Q over sine Q plus cosine Q over sine Q, and that leaves us at 1 plus cotangent Q. Now we can use the power rule for the 1, and the power rule is defined as d dx x to the n is equal to n to the x n minus 1. Now, as previously described in the aforementioned video with problem 4, in the power rule we're going to take the exponent of the variable and bring it down and multiply it by the coefficient, and then with the exponent for the variable, we're going to subtract 1 from it. Now we're going to be using this constant. Technically the constant is still 1 times q to the 0th power, and anything to the 0th power is 1. So when we derive that, we find dp over dq is equal to 1 times, bring down the exponent of the variable, bring down q to the 0, bring down the 0, and that will cancel everything out, and we'll just be left with 0. And then the derivative of cotangent q is defined as negative cosecant squared q. Now we can explain that in depth through the use of the quotient rule. Here's an example of the quotient rule that is not the problem itself. D to the dx of x over x minus 1 is equal to the denominator squared below the numerator, the derivative of the numerator times the denominator minus the derivative of the denominator times the numerator. This is the example played out, which is the derivative of x times x minus 1, which is 1 times x minus 1, minus the derivative of x minus 1, which is the denominator, which is just 1 times the numerator, which is x. That leaves us with x minus 1 minus x over x minus 1 squared. You must square the denominator in this quotient rule. And that leaves us with negative 1 over x minus 1 squared. Now we're going to be using the quotient rule in our basically solving for the derivative of cotangent q. Now cotangent q is equal to 1 over tangent q. The derivative of 1 over tangent q is, we're going to be using the quotient rule, so d dq of 1 over tangent q is equal to tangent q, a d dq of 1 minus 1 times the d dq of tangent q, and all that is over tangent q, which is the denominator, squared. And the derivative of 1, as previously mentioned, the derivative of a constant is equal to 0. So 0 times tangent q is 0. And then the derivative of tangent q is secant squared q. So we've got 0 minus secant squared q in the numerator, and then tangent squared q in the denominator. And secant squared q is equal to 1 over cosine squared q. Don't forget the negative. And that is the numerator over tangent, which is sine squared q over cosine squared q, and the cosine cancels out to just leave negative 1 over sine squared q, which is equal to negative cosecant squared q. And that brings us back to our original problem, which is the derivative of p is simply negative cosecant squared q.